Welcome back, everyone. This is Containers from the Couch. Good to see you again. And if you're a regular, you probably recognize that we have Pavan Mystery joining us again, and so I bet you can infer what that means. That means today we're going to be talking security. So let's do a quick round of introductions. And then let's get right into it. Pavan, why don't you go first?
Yeah, sure. Hey, Brent. Hey, everyone. Thanks for joining us. To the viewers from across the world, and who will be joining soon. So yeah, glad to be back. It's been a while, Brent. It's been some time. So good to be back on the show with the guests we have. Very exciting topics we are going to cover in the next hour. So very happy for new joiners and new viewers that we have on our stream. My name is Pavan Mistry. I'm a senior developer advocate with our container services within AWS, and have been in other roles previously as a security specialist solutions architect and as a program manager as well. So with us, we have Jonah Jones. I'll let Jonah introduce himself from Sysdig, and today we are joined by Sysdig, so you can guess what we are going to talk about.
Hey, I'm Jonah. I've been on here once or twice, so thanks for having me back again. I'm a container solutions architect, focused on partners at AWS. I also am a contributor to the open source CNCF project Falco Security. And I also work with Sysdig, the company, so I work on both sides of the house. I'm really excited to join the call today. Thanks for having me.
Awesome.
Great. Thanks, Jonah. Awesome. Thank you for joining us. And we have Loris De Giovanni from Sysdig as well. I hope I got your second name right, Loris.
Very well done.
Excellent.
I can tell you practice.
Yeah.
My name is Loris De Giovanni. I am founder and CTO of Sysdig. Sysdig is the second company I started in my life. The first company was called Case Technologies and was the company behind an open source network analyzer called Wireshark. Nice. So I have done open source pretty much my whole career, starting businesses behind it. And the first part of my career was computer networks and network packets, in particular, anything related to that. And now the second part of my career with Sysdig and with tools like Falco, who I was one of the people who started in 2016. I focus more on like containers and security, and in particular, runtime security.
Awesome. Thank you. Glad to have you both, Jonah and Loris. We are excited about what we're going to talk today on Sysdig and what Sysdig has to offer, especially in the context of containers and container security. So when it comes to working with containers, I think a few of our joiners or viewers know that containers have to be stored somewhere initially when they are built, and that storage is the registry, essentially. It could be Docker Hub or ECR Public or wherever, and there are a number of registries available. But then once you have that stored and you want to run those containers, that's when containers go into runtime. Can you explain us a bit about that process, Loris, in terms of the cycles that containers go through and why security within those cycles is important?
Yeah, absolutely. Going back to history, the container revolution was started by Docker, right? Initially, and the idea was relatively simple but very powerful, right? We, from one point of view, we take advantage of Linux pieces of functionality like C groups and namespaces to execute something in an operating system in an isolated way with its own like process IDs, with its own view on the file system, on the networking, and so on. But the other powerful thing that is that Docker brought essentially to the table was the Docker file. So the ability to package these components, these pieces of software, in a way that is a well-known, well-documented, community-agreed format, so that these applications can essentially run everywhere, right? You remember in the early container days, a really big, value for running containers was you can run exactly the same application packaged in the same way and with the same environment on your laptop, on AWS, on somebody else's machine, on a server, and so on. So typically the process of building and running containers starts from taking the components that you need to run, creating a Docker file, running Docker, or running something that can package them together and create the image. Once the software is packaged in the image, you can either just run it locally or wherever you want, or yes, typically the container goes into a registry, right? So a place, public or private, where these images go. And this is sort of the first place where, from the security point of view, we can start supporting essentially the process of running containers, right? Because software can be scanned for vulnerabilities as it's created and it's packaged by CI/CD tools or like by the pipeline, or software can be scanned while it's in the registry, so that you can know, you can be sure that all of the images that go in your registry check at least the basic checkboxes in terms of not having dependencies with CVEs, using the right operating system, having the not having dangerous tools inside, and all this kind of stuff. From the registry, essentially, at this point, we need to run, these images. And typically, nowadays, in the modern world of containerizations, we have somebody running containers for us. Typically, an orchestrator like Kubernetes, or if you're in the cloud, something like ECS, so container runtimes that a cloud provider like Amazon offers you to make your life easier, or also manage Kubernetes implementations like EKS in the cloud, so that again you can have the power of an orchestrator like Kubernetes, but completely managed by AWS. The orchestrator does what the name says, orchestrates container, right? So takes these containers from the registry and based on some kind of specification that you give written in YAML, takes these containers and runs them on physical machines. And this is where you go into the runtime, and when you start talking about runtime security.
Excellent. That's an excellent explanation, Loris. So it was so it gives us a context around how these containers, which are stored in registries, are being moved from storage essentially into runtime, as into memory, into processes, for example. Mm-hmm. So when they go into memory, and that's when you move from the static checks like the vulnerability assessment checks, which a lot of container customers and container security advisors have focused on. So I think there is, if you look at the available solutions around container scanning, there are a number of solutions out there, open source solutions as well. But in terms of when the container moves into a runtime, that's what excites me, and that's why this session is very important and interesting to me. We did a few months ago, we did a session on Fargate, AWS Fargate, which is a managed compute service for our AWS EKS and Amazon EKS and Amazon ECS services. So Fargate provided this functionality, which we announced in April last year, around cap sys ptrace. So sys ptrace is a capability which we opened up for customers to leverage and look at the runtime capability. And one of the things we partnered with Sysdig on was how can we enable customers to do those checks. So the link has been just shared. So thanks, Brent. So that is a link to our discussion, actually our demo. And that was our initial step into talking about runtime security on this show. And now what I'm really excited about is what else can we do here? So Loris, in terms of the actual Sysdig service, can you talk about the product you have around this, where we talked about Falco? Obviously, Falco is an open source project, but can you give us an insight into what Falco does, please?
Yeah, absolutely. And this really ties to what you were saying in terms of, runtime security, right? So, of course, the beauty of having the concept of container image and registry is that there are many tools, as you were saying, that are able to essentially take care of checking the basic, dependencies inside containers and so on. But then containers need to run somewhere. And typically, they run in complex, heterogeneous environments with an orchestrator that takes decisions for you. Like, let's run this Redis container here. Let's have 3 copies of it. And let's run, I don't know, a GNX and your Java middleware in this other place. And let's have, 6 copies of them or stuff like that. So you essentially have both the software you write and the components, the infrastructure components around it that are orchestrated and scaled up and down by the orchestrator. So it's very important to understand what's happening as these applications are orchestrated and run. And it's very important to do it in real time and get both detection of potential issues and protection from these issues in real time. Falco is an open source project. It's incubated by the CNCF, and Falco focuses on runtime security for containers. Falco is an engine that essentially is based on capturing traditionally signals from the kernel of the operating system where the containers run. As I was saying before, thanks to namespaces and C groups, it's possible to run multiple containers on the same machine. So one thing that is possible to do is instrument the kernel of the operating system. We do this typically through a mechanism called Ebpf, which is very interesting by itself. If you want, we can talk a little bit about it later. But
I kind of want, but yes, keep going.
But the summary is, through this mechanism, we can extend the kernel of the operating system, so we see all of the microscopic activity that all of these containers do. Falco leverages essentially this kind of instrumentation, which is in a set of libraries that have actually just been donated to the CNCF as well, and as a rule engine on top of that. So with Falco, you can express rules, conditions like, hey, let me know every time somebody spawns a shell in one of my containers. Or, hey, I would like to know every time somebody tries to modify a system file, I don't know, a system binary in any of my containers around my fleet. Or, hey, can you let me know every time somebody tries to exfiltrate, to read any data from these mounted file systems in my credit card validation service, because this data is important to me, Or one last one, hey, could you let me know every time service A is talking to service B, because they shouldn't be talking, I know that they shouldn't be talking to each other. Falco has a rule engine that allows you to express all of these conditions and then uses system calls to validate that this kind of stuff doesn't happen. And if it does happen, it sends you a notification and there are many ways to receive these notifications. Traditionally,
Lawrence,
yes.
Are there preset rules that Falco comes with, or do you have to write all of these yourself?
Exactly. That's a very good point, John. And
that sounds like a lot of work.
Of course, you have the flexibility to write your own rules, but I would say the large majority of the Falco users actually doesn't go into the process of writing their own rules, because Falco comes prepackaged with a bunch of rules. At this point, it's probably the ballpark of 100 or so, rules that try to cover all of the main things that you need to go, and you need to make sure don't happen, when you have an infrastructure that is running containers. And these rules are sort of curated by the community, and come essentially out of the box. So when you deploy Falco, essentially it's like a tool that typically you deploy, like for example, as a daemon set in Kubernetes, to make sure that you have one instance of Falco that is running on every machine, or you can bake it into your AMIs, on EC2. And once you have Falco running everywhere, Falco essentially already has this set of rules. So the default usage of Falco is just deploy it, run it, make sure that it runs everywhere in the simplest possible way, and Falco will just start letting you know.
On that note, we have a couple of questions. Denny 111 or 1111 asks, is it written in Go?
So, Falco itself is written in C++. And there are a couple of reasons. One is it taps deeply into the kernel of the operating system. So part of it had to be written essentially in C and C. In C++. The other reason is when I started it, and in particular when I started the components at the base of Falco, I started doing it in C++ because it was some partly the background of an old person like me. As you can see, the hair is getting white.
Hey now.
And partly just a lot of inspiration, and here we go a little bit into history from Falco is TCP dump and Wireshark. Falco and its libraries can take captures, trace files that are actually compatible with the Wireshark one. So there's quite a bit of DNA there from all their tools that are written in C++.
Yeah.
Now, as we speak, so first of all, Falco is already extensible in Go. So the fact that it's written in C++ shouldn't scare you, because if you want to write an input or an output for Falco, you can do it in Go.
Okay.
And we are in the process, and I'm personally involved with that, into really extending Falco quite a bit, quite heavily, with a plugin system, so that specifically targeted toward Go, so that a Go developer will be able, for example, to integrate Falco with a new service in AWS without having to write a single line of C++. So
nice.
C++,
cool.
It's for some reasons it's C++, but we're very, very friendly to Go developers. And if you're Go developers, please come to our community. There's space for you too.
Nice.
Yeah, there's already a gRPC server that you can expose, right? And that's how some of the other components around Falco are in Go, like the exporter and Sidekick. And are they using the gRPC? Is that how it kind of ties together?
They are using, at least some of them, they are using the gRPC interface. There's both an input and an output interface written in gRPC, so that you can add essentially stuff that Falco can understand in any language, but especially Go, using gRPC. And then, yes, tools like the Sidekick are written in Go and leverage this interface to essentially interface Falco with the rest of the world.
So we had another question that came in from chat. Jivodin mentions, and I think you kind of alluded to this, just install it and you'll start getting alerts. Well, they said, we tried Falco open source over a year ago. We found it to be too noisy, but it was easy to deploy into EKS, just lots of alerts. And then the Popcast says that there's a capability to filter rules or outputs, and that they should check out Sidekick. And they're gonna Jivo Den says we'll give it another try. But maybe you could talk a little bit about just, you know, what's the step past that out of the box experience? How do you get it to really do what you need it to do?
Yeah, and I would say, first of all, with specific reference to this comment, I would recommend the commenter to maybe try again, because noise is definitely something that, I mean, a tool like Falco, and I don't know, Falco, for example, was inspired by SNORC, you know, the network intrusion detection system. I don't know if you remember the tool based on packets, you know, but based on that, intrinsically, these kind of tools tend to have some level of noise. But the beauty of Falco is also there's a community, you know, around it that continues aggressively working toward many things, including making Falco more usable out of the box and less noisy.
Nice.
So compared to like 12 months ago, I would expect the out of the box experience with Falco to be much less noisy. And if anybody, you know, listening tries Falco and still finds that there are too many events coming out, please reach out to us. We have an active community. We have a Slack channel where you can come, and we're always happy to work with you. Then,
Awesome.
From that point of view, yeah, tools like for example the Sidekick that we've already mentioned a couple of times are definitely another level of help, you know, because
Can we
should jump in and
Yeah.
just take a look. We're 20 minutes in and we still haven't even demoed.
yes,
let's get into demos? Yeah.
Do you see my screen?
Yes.
Yes.
First of all, a couple of diagrams. The Farc architecture is pretty simple. Essentially, you have input, which is, as I was saying before, system calls and events coming from the kernel of the operating system, but also other stuff like container metadata, Kubernetes audit events, and so on. And then you have an engine, which takes this input and as you know, rules that are applied. And then there's outputs, you know, gRPC, webhooks, syslog, SDKs, and so on. Essentially, what Sidekick is it's something that receives the output of Falco and does that in a distributed fashion. So the Sidekick is something that you typically run wherever you run Falco. It's a separate container. It can be a sidecar, you know. And essentially, Sidekick and Falco have been designed to operate together, you know, to be like best friends. And as Falco is essentially the analyzer and the rule generator, Falco Sidekick is what takes the events, the alerts that are generated by Falco, and treats them, does something with them. So that something includes a lot of integrations, you know, Slack, Prometheus, Loki here in the slide, Influx, Sysdig, Kafka, or a bunch of different AWS services, Lambda, SQS, SNS, CloudWatch, S3, which is one of my favorite ones because it's just the ability to essentially receive all of this information out of the box in an S3 bucket. And Sidekick is able to integrate with all of these services and essentially offers both the collection functionality and the routing functionality and the integration with a bunch of different tools. So essentially, Sidekick makes Falco talk to the rest of the world, which is a super important function, because otherwise, per se, Falco is just, you know, writing stuff, you know, to the standard output of the local machine. Then Sidekick also is a user interface. So when I'm using Sidekick, I can also essentially log in and start getting, you know, real-time statistics about what's happening in my infrastructure, and I can essentially, you know, quickly filter. For example, I only want to see the critical events, for example, and Sidekick is able to show me, you know, only the critical events that I'm receiving. But I can also go and quickly browse the specific events and get information about In this case, for example, I have applications that have set UID or set group ID bit and other stuff like that. So,
hey, Loris.
Yeah.
While you're on that, I heard there might be an Easter egg in there. Could you go back to the events and filter by warning? I'm just curious.
Let me go back to the dashboard here.
Go to events and filter by warning.
Okay.
Take a look. Let's take a look at the pod name. I'm curious if this is the same one I was ticked off about. What is the K8's pod names? So I know who set up this demo then.
Wait, I don't see it.
Take a third on the first event. Take a look. In the blue space.
Yeah. Jonah.
Oh yeah, look at that.
Yeah,
that's great.
Yeah, that's awesome.
We had them pop creating this demo for us, so definitely nice trick.
Great.
That is good.
Rules works on a couple different levels there, right?
Yeah, I guess that's a warning to have my name in there.
Exactly. So that's Sidekick in a nutshell here, and let me again, Falco and Sidekick at this point well designed essentially to work exclusively together. But Sidekick at this point is used by Falco, but also by other projects. So it's very nice to see a community spawn a project that then is starting living life of itself and really bringing strong and independent value to the community.
I think this is really powerful, Loris, in terms of the way I see our customers utilizing this is previously when we looked at the Sysdig trace integration, we only had the visibility through our CloudTrail logs and any events that would appear once we had configured Fargate in a way it could push to CloudTrail. Now we can, using Sidekick, we can use a number of other kind of event sort of engines and send it out to different places that customers may want to do more analysis and alerting based on real-time activities and prioritize those, right? So this is a great update. How can we configure this? I mean, how do we go ahead and enable this?
So there are many ways to deploy Falco. This depends a little bit on your environment. Probably from the user friendliness point of view, I would say the Helm chart is my favorite one because it allows you to essentially deploy it in the cluster in a way that is easy, transparent, natural, and almost one-lineary. We offer other ways. For example, there's an operator for Falco for Kubernetes, if you prefer that approach. And of course, Falco is not limited to only run, in Kubernetes environments. So it's absolutely. So first of all, Falco is an engine, works very well with containers, and we could say specializes in containers. But absolutely, you can run Falco on your local machine, and you can absolutely. It's also a great host intrusion detection system. And typically, when you deploy that way, any deployment method like RPM or stuff like that works. Or again, baking it inside the AMI works very well.
So if Falco's open source, it works with Kubernetes, it works with containers, but it can also be a host intrusion detection system, then what's that next level up? What can you do once you have Falco running and you just want, that next level of tell me if I'm SOC 2 compliant or tell me if I'm PCI compliant? Is that possible?
Yeah, so couple of levels here. One is from the open source point of view, as I was saying, Falco comes with a bunch of out-of-the-box rules, and some of these rules have actually been, designed and contributed to Falco to essentially check against these compliance standards. So that, and we tag and label rules for this, so that you can easily, for example, start Falco and with a subset of rules for PCI compliance, for example. In addition to that, typically when you are concerned maybe into bringing your runtime security to the next level and elevating the game with a bunch of other functionality like audit logging, compliance reports, image scanning, and so on. That's when you maybe go to a commercial product, like, for example, Sysdig Secure. Sysdig Secure is based on the Falco engine, so that you are guaranteed that there's full compatibility. And if you have your own, like, customized advanced Falco rules, you're absolutely able to keep running them when you run Sysdig Secure. But for example, Sysdig Secure has a whole part of the product user interface that is just devoted to PCI and compliance, and can orchestrate the different Falcos that you have to apply, all of these compliance checks, put it together with benchmarks that are run on every machine and for every container on a regular basis, and create essentially nice consolidated reports that tell you essentially what your posture from the compliance point of view is and what your trends have been. And this is something that essentially you can decide to spend money on to get a commercial product like Sysdig Secure.
Nice.
So
Yeah.
if you don't want, oh, sorry, go ahead.
Sorry, Jonah, go ahead.
I was just gonna say, if you don't want to spend money, didn't you guys just launch something that was a free tier? I did see a blog announcement about that.
Absolutely. So let's maybe talk a little bit for a second. So a couple of concepts. One is more and more our view, but I would say the view of the full industry is people run their applications in the cloud. So everybody's more, I don't have to explain this here, right? The cloud is the future from one point of view. This is one trend. And the other trend is workloads more and more that are migrating to the cloud in a substantial way are running in containers, because containers are the natural, way to run modern workloads. So we have essentially, especially from the security point of view, workloads, which means applications running in containers, and infrastructure, which more and more is cloud infrastructure. Right. So what Sysdig has been working on is how do we put this together so that we are able to offer for the first time a comprehensive solution that covers both the workload side and the infrastructure side in a way that is not only powerful and complete, but also consistent and based on open source standards. So one of the things that we worked on is adding essentially functionality like CSPM and CWPP to our commercial product, which is useful and interesting by itself, especially since we've tried to do it in a way that uses standard tools like Cloud Custodian and other tools that are broadly adopted by the community. But the other thing that we identified was the idea of runtime security, of runtime protection, which is at the core of Falco. Maybe we can extend this idea to cloud infrastructure. For example, we can take the Falco engine, which is a generic, powerful engine that you can use to express security rules, and we can make, through this concept of inputs that we were showing before, we can make it able to understand stuff like CloudTrail logs. So from one point of view, CSPM, Cloud Security Posture Management, is based on once in a while go and use the AWS APIs to make sure that everything is okay. You know, the buckets are secure, the accounts have the proper posture and so on. But by using Falco and CloudTrail, we can also, in addition to that, have a runtime component that is able to notify you every time something happens. So not once in a while making some checks, but as Falco does, every time, I don't know, a user changes the properties of a bucket to make this bucket public, there can be a Falco alert. Because what happens? When the user does this, a CloudTrail event is generated. Falco is absorbing the trail of events generated by CloudTrail, and there's a Falco rule for that. And then through the sidekick and all of this beauty, it's possible to receive these alerts.
So that kind of turns it into real time as CloudTrail is.
It's runtime, cloud and cloud infrastructure security.
Yeah.
And this is something that currently is something that we just announced is part of our commercial product, and we've extended essentially the Falco engine, and we created a bunch of rules for the different AWS services, 200 plus essentially detection rules, so that EC2, S3, but also the more sophisticated / sometimes esoteric services, there's all good protection out of the box for this. And then what we did was we created a free tier for this. So you can go and you can get a login, and you can protect essentially one of your cloud accounts through this free tier that has essentially full functionality and includes a bunch of, important things that you need to do with your application, small or big, and with your cloud infrastructure, small or big, with a nice packaged user interface where you can essentially get it for free forever with a nice SaaS user interface that is nicely integrated with your services.
I would be almost scared to unleash that on my account. I've had so many starts and stops and do things and undo them and all that. Countless thousands of times. So I'm wondering, I should launch it and see.
We should add a functionality called brand shaming in the product.
Yeah, exactly.
That makes it available for the public.
It'll just convince me. Throw the account away, get a new one. That's probably the better move.
That's great.
And we try to package these in a way that can be useful, by the way, for small and big. So you don't need to be like a big enterprise to take advantage of this. Especially the free tier is really designed to cover the important checkboxes for people that maybe I have a small application. Are transitioning to the cloud or something like that, and it's important. We hope, of course, we're a commercial company and we have products to sell, but we truly hope that we bring a little bit of value in making AWS and the world as a consequence, because the world is running on top of AWS, a little bit more secure by offering something that you can use for free. And there's, image scanning, there's a bunch of stuff that is just a must, when you're running your applications in the cloud. And security is so important nowadays,
Absolutely. I think in terms of small to medium-sized businesses who are looking to look at containers and have compliance requirements, pressures from the regulations on complying against certain standards, product like this would be very useful, tremendously. The rules you mentioned then, Loris, are they configurable? Can I align it to my local policy, like security policies? The use case I'm looking at is I get questions from customers around running PCI compliant workloads on Fargate, which they can obviously do, but then using something like what you described, can I align those requirements to this feature?
The answer is yes. and that's where the beauty of leveraging Falco comes into play, right? Because imagine, typically when people have, to maybe worry about their security for their cloud infrastructures, then, you have a product with a syntax and a set of rules for this cloud service. And then you have a different product for containers. And then you have a different product with a different syntax and different set of rules for virtual machines, like instances, like EC2 and that kind of stuff. Soon enough, you are complete. You don't even remember if the syntax you're using is for this or for that, if this rule that you're receiving in this different user interface and so on. So that's where the idea of, okay, Falco for everything, one language, one set of tools, Sidekick that supports everything, a single community where you go for this kind of stuff, a simple way to expand this, and the single place to put all this kind of stuff. The syntax is the Falco syntax, but we have the ambition of having the Falco syntax, the Falco engine, rule the world. Not because we want to conquer the world, but because we think that it's going to be so much better and so much easier for the users to just have to worry about one thing. So you were asking, can I, maybe extend this and customize it for my own needs? And the answer is yes, because it's Falco. Not only you can, but if you see a Falco rule and you're familiar with that and with a relatively simple syntax, you can absolutely, and you have written maybe a rule to protect your containers from some particular condition for Falco in the past. Now you can write a rule for I don't know, EC2, or for whatever you might have in terms of services in the cloud. And now there's a community. So if you write this rule, this can be something that the rest of the community benefits as well, because it's not trapped into just a proprietary product.
That's really cool.
Yeah. You mentioned previously about the donation you made to CNCF. Can you talk a little bit more about that?
Yes, and this ties also to you were talking a little bit about Fargate before, right? And which is per se an interesting topic, because being able to essentially provide like the Falco level functionality in Fargate, where there's no access to the kernel of the operating system. You remember I was talking about Ebpf and getting the events from the kernel and system calls and all this kind of stuff. In Fargate, containers are run by Amazon, which is beautiful, and I don't see why no one wouldn't want to do it, but at the same time makes this kind of instrumentation very hard. So all of the logic of for instrumentation underneath Falco, underneath open source Sysdig, underneath many other essentially tools in the ecosystem, is part of what we call Falco libraries. And these the term libraries here is a limiting term, because in practice the Falco libraries not only contain the libraries that are used to get this data by applications, but also the components like the kernel module, the Ebpf probe. So all of the sophisticated components that have been developed across years and years and years to make sure that tools like Falco can run, because the best data is coming from all of the different possible environments. These libraries have been originally written by Sysdig. I was one of the original creators of these libraries. And when we contributed Falco to the Cloud Native Computing Foundation, we contributed the engine, but not the libraries, not these collection components, for a number of reasons. One was that other tools were using these libraries. The other one was that they were still not in a shape that was, let's say, elegantly packaged enough that we felt comfortable to give this to the community. So one of the great things of working together with something like the Cloud Native Computing Foundation is you make a commitment to openness. One of the reasons I believe that Amazon has been working with us on this is because Sysdig has decided, okay, let's give this to the broader community, to the Cloud Native Computing Foundation. Let's make Falco. Let's make this a tool by everybody for everybody, and so the Cloud Native Computing Foundation pushed us, in terms of, okay, these libraries, if they are an integral part of Falco, it would be better if they become, community owned, exactly like Falco, and they are not, even if they are open source, in the repository of a specific company. And so we did it. We did it around a month ago, and essentially it took a non-negligible amount of time, but we were able to separate these libraries, make them an independent project, document them, and just give them to the Cloud Native Foundation as essentially a sub-project in the Falco organization. And so at this point, these libraries are copyrighted Cloud Native Computing Foundation, and everybody can feel confident to use these libraries to build security tools, introspection tools, troubleshooting tools, or anything else, because this is the source of truth. And even when we support, for example, Fargate, which took a really serious amount of work, because we had to come up together with Amazon, which was nice enough to work with the Falco community to open up the ptrace capability for Fargate containers. We essentially came up with an implementation, fully user-level implementation of the Sysdig instrumentation that doesn't require the kernel module and so on, but at the same time is efficient. This is part of the libraries. So when we've done this work with Amazon, the work goes there. Falco immediately benefits for it. Other tools like open source Sysdig immediately benefit for it. Vendors like Sysdig, for example, in the commercial products, but other vendors as well, immediately benefit from it, And there's a virtuous circle in the ecosystem, because at this point, people can enjoy the same level of security for example, Fargate, because it's something that Sysdig and Amazon were able to work on together and contribute this piece of functionality called PDIG that can be used for this kind of stuff. So that's the philosophy behind the donation of the libraries to the CNCF.
That's fantastic.
That's awesome, Loris. Yeah, thank you for that donation. And it's so much important in terms of security, as you mentioned. In our demo, we looked at how we can use Fargate with Falco and ECS as an orchestrator, but we can use it for any other orchestrator. It enables a low-level kind of visibility and security for so many workloads, and that is so much valuable for our customers. So appreciate that. I think it also enables understanding of Ebpf in use, which is where a lot of learning needs to take place. I think personally, from a security perspective, whilst we are coming out of the traditional EC2 kind of security mentality, or the virtual instance security mentality, we need to work around and develop the frequent deployment that we see with cloud container workloads, have mechanisms like Falco to monitor container workloads and in real time, and how we respond to those threats is what I'm interested in as a security professional as well. So is there a link? Sorry, Brian, go ahead.
Oh, I was just going to say, we've talked about Ebpf, but let's define let's tell everyone, what is Ebpf? And I don't know, Pavan, do you want to take that one, or?
I can give it a go, but I would go back to the creator of Wireshark.
Okay. It's fun. It's like me. Okay. So I will spend the next 3 hours talking to you about EBPF. I believe we only have a few minutes, but let me try to give you the summary and a little bit of history. EBPF stands for Enhanced Berkeley Packet Filter. So Berkeley Packet Filter because originally BPF was a functionality that was initially introduced in the kernel of the BSD operating system in 1992-1993 by Steve McCann and Veg Jacobson, two researchers at the forefront of the research on TCP and many other things, and also the creators of TCP dump. Originally, BPF was just implemented as something that could be used to create filters for TCP dump. So when you run a TCP dump, I'm sure everybody's familiar, TCP dump port 80, this is translated into like a little program that can be executed by a virtual machine that is in the kernel of the operating system. That takes this program, validates it so that it doesn't crash or does something bad, and then runs it to just filter the packets. So when you do TCP dump, you only receive the packets for port 80. So that was the revolutionary 30 years ago concept of having a virtual machine in the kernel of the operating system so that you could just run programs in the kernel that at that point were interpreted, okay? But just the idea, a kernel, the most like critical things that you can imagine could run scripts. And there's quite a little bit going on, to do that. Fast forward 30 years, there's been a huge amount of work in these years in the Linux community so that BPF now is not limited to packets anymore. It's just a standard, powerful virtual machine that is able to just-in-time compile scripts to run in the kernel of the operating system and validate them so that you can write complex pieces of software that go in the kernel of the operating system, and they are guaranteed not to crash the machine. They're guaranteed not to create loops that could freeze the kernel or the kind of stuff, because there's a complex validator in the kernel that makes sure that those programs are safe. Nice. And then there's a powerful tool chain on top of that of compilers, of backends for like LLVM and so on, that you can write in C or other languages, powerful languages, essentially modules for the operating system. So fast forward to this, and now eBPF is essentially the most exciting thing that is going on in the kernel, because there's work and research, universities and companies that are working together to essentially keep making it more and more powerful and hooking it in the networking stack, hooking it like what we did with Falco and Sysdig into like a security, runtime security and detection and the kind of stuff. And now it's possible essentially to do all of this kind of stuff in the Linux kernel with a vanilla kernel by just having these very powerful scripts that run in the kernel. The Falco collection is based essentially on this concept. Take a kernel, safely expand it so that there's hooks that are able to collect the system calls, every single system call, deliver them through eBPF to a user-level program called Falco, and that Falco do all of the magic in terms of detection and all of this kind of stuff. There's a 4-minute summary.
I'm impressed. That was awesome.
Last 30 years of history.
That's fantastic. Well, we're about out of time, but you've definitely given me a lot to go off and play with, because, like I said, I do have this account that is just in a terrible state. I'm curious to see what Sysdig. I have something talking to me. I don't know if you could hear that or not.
No, we can't.
Okay, good. I think I have. It's one of my, assistants.
Robots.
Yes. But anyway, I definitely want to try this out, point it at some of the workloads that I have running that are more or less ephemeral and doing weird things. And I'm curious to see what it comes up with. But I love this. Love Falco. The sound of that is just incredible, and I love that it's the basis that you can build on. And you can move into, I like that there's a free tier for Sysdig, and then as you continue to grow, by this point you've found value. You've seen the value in the open source tier and the free tier, and then if you want to continue growing into it, there's a path forward, and you can handle all of your security needs. So that's really cool.
And everybody's welcome, in particular Falco. Jonah, both John and I are, part of the community, are on the Slack. So if you want to give Falco a try, go to falco.org, come to the Slack channel, and we will be very happy to welcome you.
Great. Yeah, I would like to follow up on what Brent said. In terms of my kind of vision around the products such as Falco is, it's early days for containers. I mean, in terms of the workloads we are seeing in the enterprises, but it reminds me of the requirement around antivirus. For example, PCI says, okay, you need to have antivirus installed on instances, right? So Falco kind of is a de facto runtime security product for providing that sort of security for containers and more. I mean, it's not just limited to containers. It's as we discussed, a lot more. So appreciate all the insights you brought in today, Loris and Jonah, and we'll do follow-up sessions. I'm excited to dive deep into this and work with our services and see how this works. I have an open source kind of deep dive into Fargate, Falco, and ECS in my GitHub repository. So feel free to have a look. Also, there is the YouTube session that we did on Falco and ptrace if you really want to get hands-on with this. So I'll look forward to do follow-up kind of demos on this as a developer advocate in security. So again, appreciate your time, guys.
Thanks everyone.
Yeah, thanks for having us.